If you thought that heat pumps was a recent development, you would be wrong. Heat pumps have been around at least since 1850, when Peter von Redinger, who was an Austrian inventor, installed a heat pump system on the Zurich City Hall. Today, each year, the Redinger Award is given in recognition of achievements in heat pump developments. The first heat pump in the United States was developed in 1948 by Robert C. Weber, an American inventor who came up with the idea for a ground source heat pump when he was experimenting with his deep freezer. He accidentally burnt his hands when touching the outlet pipes of the cooling system, and he decided to see if the mechanics could be reversed. In 1960, 1.8% of homes in the U.S. used electricity for heating. 81% of homes used fossil fuel for heat. In 1970, 7.7% of homes in the U.S. used electricity for heating. The oil crisis of 1970 made heat pumps even more attractive. In 1980, 18.4% of homes in the U.S. used electricity for heating. Before 1980, SEER ratings were 6 or less, and HSPF was 6.8. In 1992, the DOE raised the standards of SEER to 10 and HSPF to 6.8. In 2006, DOE again raised the standard of a SEER to 13 and HSPF to 7.7. In 2015, DOE raised SEER to 14% and HSPF to 8.2. So today, the energy savings is the big thing in most people's minds. And as you can see over the years, 8 SEER, there was 0% of savings, whereas today, there's 65% of savings with a 23 SEER. So energy savings have gone up, and air conditioners and heat pumps have become more and more efficient. All of your units today have an energy guide stamped on them, and this is what the homeowner is basically looking for to see what savings they're going to make on upgrading to a new higher efficiency unit. So the higher the SEER rating and the HSPF, the more savings they will see from that unit. So the SEER, or Seasonal Energy Efficiency Rating, is the cooling output during a typical cooling season divided by the total electrical input during the same period. Typical SEER ratings start at 13 and can go as high as 21 SEER. HSPF, or Heating Seasonal Performance Factor, is the ratio of heat output measured in BTUs over the heating season to electricity used measured in watt hours. In 2023, the national HSPF standard was 8.3, and it will be going to 8.8 soon. Inverter technology is everywhere, not only in ductless product, but also in split system residential and light commercial product. This is driving the efficiency ratios of equipment through the roof. Inverter technology in ductless has been driving the market, as the ductless market can run down to minus temperatures and still produce a lot of heat. This technology is now coming into residential split systems, so a standard heat pump with an inverter driving that heat pump can run down to much lower temperatures than a standard heat pump. So when trying to explain inverter technology, I use a modern airliner which lands at speeds in the range of 150 to 170 miles an hour, depending on their weight at landing. This means that the wheels on the landing gear that are not turning at all must go from 0 to 150 or 170 miles per hour in a matter of seconds as they hit the concrete. This places extreme wear and tear on the rubber tires. In an HVAC system where the compressor is controlled by a contactor to start the compressor, which is sitting there idle, the compressor must go from 0 to operating RPM in a matter of seconds. As with the tires on the airliner, this puts the compressor under great stress at startup. But in an HVAC system where an inverter controls the compressor operation, the compressor starts slow at low RPM, and depending on the load will slowly ramp up to operating speed. And when the cycle is complete, the inverter will slow the compressor down gradually to complete shutoff. This reduces the wear and tear on the compressor, increasing the life of the compressor. Another thing that you'll find on modern heat pumps is that instead of having a thermal expansion valve which meters the refrigerant into the outdoor unit, we have electronic expansion valves which allow for much closer control of the refrigerant being metered to the outdoor unit. This, in combination with an inverter control, will allow the heat pump to run down into minus temperatures and still produce a lot of heat. So in 2020, 18 million U.S. homes heated their home by using a heat pump. It is projected that by 2030, that number is expected to increase to 20 million households.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.